Okay, so here's a problem out of the book, 896. I like this problem. It may be a little too much for the exam, but it works it two different ways. So it wants both the maximum and the minimum value of this weight over here that's hanging vertically that can be applied without letting this 50-pound block on that incline slip. And you got coefficients of friction between the block and the plane of 0.2, and you've got also over the drum you have friction to deal with. Okay, so let's start with some free body diagrams of the problem, and let's see what we can solve. First thing I'll do is I'll start with this block here on the left. So let's draw the free body diagram of that block. So there's our block. It weighs 50 pounds. So acting through its centroid in the center there is the 50 pounds. We've got a tension force in the cable. I'll just call that T1. And then we have a normal force. I'll call that N1. Now, which way is the block going to move?
Left.
Well, let's see, if we do the maximum weight, the block will move up the hill. If we do a minimum weight, the block is tending to move down the hill. So we're going to have to do two of these. Okay, so let's first think, we'll do, since it says maximum, we'll do maximum first. So when I put a maximum weight here on W, it's going to tend to go down, the block is going to go up, so the friction force is down. Okay? The first thing I know, since it's on the verge of motion, then I know that my F1 is going to be related to N1. So really there's just one unknown here. I'm also going to make this a little easier for me to deal with by, let's see, what's the best way to do this? I'll do it over here on the side. I'm going to assume that this is my X and Y axes. That's going to save me a lot of trouble because now my F forces, my N force, my tension force are in XY. I only have to break the load down. And since we're talking about that, let's go ahead and indicate that that's acting at a 45-degree angle from my assumed y-axis. Okay? In fact, I'll call those prime just to let you know that they're not our normal set. So let's go ahead and do then, let's sum forces in that y prime direction. Make sure it's in equilibrium. So what do I have in the y direction? I've got N1 acting up, and then I have the y component of this, which is acting down, which will be 50 pounds times the cosine of 45. Well, I can solve for N1, right? Oop, did that wrong. 35.35 or 35.4? You guys get that? So then I can sum forces in the x direction. Or actually this x prime direction, this rotated set of coordinates. And what do I have? So in the x direction I have T1 minus F1, and then minus 50 pounds sine 45. Now remember, F1 is related to N1, so I should be able to solve for T1. So T1 should be equal to F1, which is mu N1, plus 50 pounds sine 45. And I know what N1 is. And the coefficient of friction on that surface is 0.2. So technically that would be 0.2 times N1, 35.35 pounds, plus 50 sine 45. So what's T1? Anybody got that? I got 42.43. Do you get that?
Well, this is max.
This is max. So we need to do it again for min. And then we're going to run it over the cylinder to find out what the actual weight would be. So that was max. Maybe I'll go back over here and write max here so you know we did the max motion. Now let's come over here and do the min. So what changes? My block is the same. Since it worked so well before, I'm going to do the same thing with x prime and y prime. My weight's going to be the same. The tension force is still the same. Normal force is still the same. Except now the block is tending to slip down the incline. So it's going to move down. So the friction force is up. And I still have, so my equations are pretty much the same, except now I have to, my friction force will be different. So I still know my relationship is still there. I'm still going to be developing my maximum friction. I still going to sum forces in the y direction, right? I'm still going to get 35.4. So what's going to change when I sum forces in the x direction? You want me to rewrite all those equations or just do the one that's going to change? What do you guys want?
The one that's going to change.
Yeah, so here we'll look at sum the forces in the x. The equation is going to look pretty much the same, except the signs will be changed. So I'll still have T1. Now I'll have plus F1. And I'll have minus 50 pounds sine 45. So I can still solve for T1, except now it'll be minus F1 plus 50 pounds sine 45, which, letting it go to its max, will be minus 0.2 times 35.35 pounds plus that. Well, the terms are the same. I'm just going to get a smaller value.
28.29.
28.29. So for me, that's the problem, kind of the minimum and the maximum. Now, to actually answer it, I need to know what the actual weight will be here. I'll have to look at how it moves across the top of the That's not a pulley. I guess the top of that peg. So let's go back and look at the maximum case. So what's going to happen in the maximum case is that which way is the motion over the cylinder going to be? It's going to be clockwise, right? So friction will be opposite that. So as this thing tries to move down, the force at W is going to be larger than T or less than T? Do we need to make a drawing? Larger, right? Because you got to overcome you're going to also have to pull on this friction. So whatever I need here in the tension, as it goes over the thing, it'll get larger. So what I'll come here is I'll now say, in this case, maybe I can squeeze it in here. So with that, if that's true, then I could say T2, which is really equal to the weight, is going to be T1 times E to the drum is 0.2. And the contact is what? What's the contact angle? Looks like it's a quarter of a circle, right? No, it's more than a quarter of a circle. It's going to be a quarter and 45. So that'll be pi over 2 plus pi over 4, 3 pi over 4. Does that make sense? Kind of squeeze that in there. So what's that going to be equal to? Multiply all that times our 42.43. What do you get? I got 86 something. You guys get that? No? Yes? Got to find the pi button on your calculator.
Actually got 68.
Don't forget. What was the number we got? 42.
44.51.
Well, I screwed up. I got 5.2 times 10 to the minus 70. What did you get?
45.51.
That didn't sound right. Sorry.
I got 67.97.
67?
Plus 68 rounded up.
I
got my 42. Because it's 42.43 times E to all that.
Okay. I've made an error. I think I've given you some bad information. I think the coefficient of friction is.
I got 67.97.
I think it's 0.3. You have your book open?
Yeah.
Well, I think it's 0.3.
It's 0.3.
So.
That's weird that it says.
I guess when I copied it over, I messed up. So the between the rope and the drum is not 0.2.
That's what I was confused.
It's 0.3. So change this to 0.3. That should make it a little higher.
Yeah, I was wondering why they even made it different.
It was.
Why would they would?
I probably was cutting and pasting when I made this document and didn't update it.
86.
86. I like that better. Considering I'm looking at the solution manual and that's what they got, so I'm happy about that.
How did you get 3 pi over 4 for your radians?
I'm looking at my contact about the center of the circle. I'll just put an X to the middle. So you can see I have a contact here, a quarter of a circle. And because it's 45 degrees, I get another half of that for contact. So there's my contact. So it's 90 degrees plus 45 degrees. See that?
Yeah.
All right, so that's one. So now we have to go to the other thing, which would be the min case. So what's the minimum load? Now the motion is, the block is going down. So it's just the opposite, right? So now, in this case, my weight is going to be more. So my weight would now be this load, 28.29 pounds. raised to E to the 0.3 and the same contact angle, 3 pi over 4. So what's that weight come out to
Would
be?
your mu also change for the T1?
No, it's still the same contact, except now it's going in the opposite direction.
Oh, yeah.
Yeah, when we did max, the weight is going down,
Yeah.
right?
Yeah.
And now we're doing min, the weight's would tend to move up. So what's that? Did I do that right? I did that wrong. That's wrong. The weight's the small, and this is where the 28 pound goes. That's the one that we already know. So we have to solve it backwards. So the weight's going to be the minimum now because it's moving towards its minimum value. It's starting to move up. So this force should be the bigger of the two. And we already know what that force is. It's 28.29, so we don't know the weight. So the weight's going to be even smaller than that. So you have to take 28.29 and divide it by this. What's that? Anybody got that? That sounds reasonable. Anybody else get 14? Yeah, I almost missed that. So it's quite a range in weights. So any weight between these two, the system is sitting there. But obviously if you go less than 14 pounds, it goes up. You go more than 86 pounds, it slides down.
It's a big difference.
Big difference. 0.3 is that's a pretty good coefficient of friction for. I guess that looks like a rope over a drum. Any questions about that one?